Welcome to the Great Zucchini's first screen hour recording. This is dedicated to Sarah for her question yesterday regarding how to do the intercepts of an absolute value function. Well, Sarah, the algebraic way I do find quite convoluted, and I was working through it on my own because I did see an error in yours, and I was on like page, well, it felt like page 100 before I seemed to think this is just not the way to think, because I'd already gotten to a solution graphically. So this is my habit, Sarah. My habit is to think about things graphically if they can be. And we're talking about an equation that generates a graph here. So let's just go directly to that. So what I'm going to do is use your instinct, which was -2 seems like a really important number here. -2 inside that absolute value bracket will generate a 0 for the function. So for anyone that's unclear about that, Sarah was able to say, well, if I want y to be 0, and she did by speculation, I think, because she started that even before she did any algebra. She knew that -2 would zero that thing out. And so we have our first intercept, which is an x-intercept at -2 and 0. Okay, so then using that as a bit of a guide, we'll just throw in a bit of a table of values. Now we have a tool. We have a tool that does this for us. It's our graphing calculator. So what I'm doing is not something I couldn't ask the graphing calculator to do in a heartbeat. But let's do it by hand just so we really get a sense of it. So I'm going to place that -2 here because I know there's some symmetry around that -2. And I'm going to try -3 and -4 and see where I get with that. And I'm going to try -1 and 0 to see what happens there. I might actually, since I know it will fit on this graph because I've just done it a few minutes ago, I'll go with a few more. Now I can see that being a question there. How did you know how to use those numbers? Well, it doesn't matter in a way what you use. You'll eventually determine what kind of numbers will fit on your graph. You can try any x you want. I could have tried -1000, but when I tried -1000 I would get a very large and a very large y that wouldn't fit on my graph. So after a few trials, you'll know what are good numbers to try. But from experience, I know that using the number that got me the 0 is going to, especially in an absolute value function, is going to give me some kind of symmetrical spot, my axis of symmetry here. So graph a number of them in this way and you will get that same information. You'll have that same knowledge. The graphical method really relies on trying and finding trends, and that's really what math is about too. Okay, so then let's take a look at -3. If I throw 3 times -3 is -9 plus 6 is equal to -3, and I'm going to place that in there in this way. I'm going to put my -3 in here, but I'm going to put an absolute value around it so that I realize that has to become a +3. And that will give me the -3, +3 point on my graph. And then I'm going to place -4 in for the x value. And when I place -4 in, that's -12 plus 6 is -6. So I'm going fairly quickly, but hopefully you can pause the recording if you need to think a bit about any of that. Don't let my pace govern your pace. Every time I say something that doesn't quite sit right, pause, back up, make sure that you can do the work in your own head to get there. So that's -4 and +6, and that gets me there. And then if I place -5 in, whoa, I didn't mean to do that. Let's just undo that a little bit. There's no undo in this whiteboard, but hopefully I can, there we go. I meant to highlight. So this is the value that we're replacing. -5 in for that spot is -15 plus 6 is -9, which when taken in the absolute value function, oopsie daisy, is equal to +9. And a point up here, and you can begin to see that we've got this slope of -3, which is what we would predict. Well, we're on the less obvious side of the absolute value function here.